All right, categories of numbers. The first big category break, I wish this copy line hadn't been there, but is right there. So everything to the left of that line are real numbers. And everything to the right of that line are imaginary. We'll come back to what that means in a minute. So the first break is real versus imaginary. The second break, like within real numbers, are rational numbers versus irrational numbers. What's the first 5 letters of rational spell?
Ratio.
Ratio. So rational numbers are any numbers that can be written as a ratio. So fractions, whole numbers, zeros. Let me just throw some things out here like 7, 2/3, negative 53 over 12. Just anything that can be written as a ratio is a rational number. You do need to be a little bit careful. That includes things like 0.333333333. So that doesn't look like a ratio, but it could be written as a ratio. So we have to be careful about rational numbers. You can't just say no decimals allowed. Like, no, decimals are okay if you can figure out or if you know that it can be written as a ratio. You know what? Let's let's talk about irrational numbers first, and then we'll get into the details of rationals. So this is stuff that can't be written as a ratio. You know what? I should be more specific. A ratio of integers. So rational numbers can be written as a ratio of integers. Irrational would be not a ratio. So do you know what kind of numbers are irrational? There's a couple of famous ones. What's that? Pi is maybe the most famous of them. 3.1415, but it's not a repeating decimal, so it can't be written as a ratio, so irrational. Also the square roots that won't reduce. So square root of 2, square root of 29, kind of stuck on those. Let's go back to the rational. So within rationals, we could have integers. -3, -2, -1. Those are all the integers. Although, you know what? I need to be careful because I don't want to put 0, 1, and 2 right there because those belong to a tighter circle of numbers. So they are integers, but they belong in a tighter circle. Whole numbers. The only number that is a whole number but not also a natural number is 0. So the whole numbers include all the natural numbers or the counting numbers. Counting numbers, it's easier to remember it that way because it's the numbers you count with. So 1, 2, 3, 4, and so on. Whole numbers, we add 0. 0 makes a whole. That's how you remember, like 0 is a whole. So the whole numbers start with 0, and then the integers include the negatives. This is also a sort of I don't know the dates, but like a history of when numbers were discovered. Like they didn't even have 0 as part of the numbers for a while. I don't know, it seems weird, but if you're counting your stuff, you got to have some numbers for that. But if you didn't have anything, they didn't say you had 0, you just didn't have any. They didn't have an idea of 0. So like hundreds of years later, they came up with the idea of 0, and then after that came negatives, and then after that came the rest of this stuff. Imaginary, that's, you know what, let's jump down to the definition of imaginary number first. Square root of -1, that's I. So that, you just got to know that. That's the definition of what an imaginary, of what I is the square root of -1. If that feels kind of made up, it's because it is. So here's where it came from and why they made it up. If you have x squared equals -1, let's solve the algebra problem out here. What would you do to both sides to get x by itself? Square root both sides. So that gets you x. Don't forget to put the plus or minus on when you square root both sides. But then here's the problem. You got the square root of -1, which doesn't exist. Like you can't, there's no number you can square and get to -1. But there are lots of places in math and in engineering even, like real world things where you need to be able to take the square root of -1 and it has actual meaning. And so someone decided, well, we need a name for this so that we can do the algebra with this. And so they just said, all right, well, let's just call that I. So I is the square root of -1. Again, it feels arbitrary because it is. They just made up that name because we need something to call the square root of -1. Back to this side, if we kind of go the other way with this, we start with I equals the square root of -1, and we square both sides. The square and the square root cancel each other out. And so I squared equals -1. How we use this. Square root of -16. I'm going to rewrite that as the square root of -1 times 16. So I can split that up again now to the square root of -1 times the square root of 16. We just learned that the square root of -1 is I. The square root of 16 is 4. And it looks a little funny to put the letter first, so we usually put the letter second. So we would say that answer is 4I. Same type thing with square root of -4. I'd make that square root of -1 times 4. Square root of -1 is I. Square root of 4 is 2. So 2I. Once you do a couple of these, you're like, wait a minute, do I really need to write all that out? Why don't I just take that negative sign on the inside and bring it outside as an I? Alright, so you try those last two, see what you get. Could probably get them before I even find the popsicle sticks. Alright, Eli, what's the square root of -49? 7I. And Audrey, the square root of -25? 5I. Good, 5I. So the square root of a negative becomes I. And you handle the rest of it like you always do. Okay, before we turn the page, let's put some Some examples under imaginary, that's just the I things. So 3i would be an example if it's already been simplified. If it hasn't been simplified, it might look like square root of negative 36, but that would be an I thing. Okay, now we're going to combine I stuff with stuff that in theory we already know, but it's been a while, so we'll do some practice here. Use the same rules to simplify radicals that aren't perfect squares. So square root of negative 20. Probably the first thing I do would be like, all right, that's I root 20, and then I'll handle the root 20. All right, so fix the I thing, and then handling the root 20 is supposed to be old news, but it's been a while and students still struggle with that. It might be a good idea to remind ourselves what the perfect squares are, because those are the factors that we'll be looking for. So 1 squared is 1, but that doesn't do us much good. 2 squared is 4. 3 squared is 9. 4 squared is 16. So these are not numbers you have to memorize. You can just build this list anytime you need it by squaring 2 and 3 and 4 and 5 and 6 and 7, and we don't usually go much past that for what you would need. So those are the factors that I'm looking for, because if I can find those factors, I can have a perfect square and I can take the square root. So I want to break up 20 into two things, preferably using one of these factors.
4 and 5.
So 4 and 5. So I'm going to rewrite square root of 20 as square root of 4 and square root of 5. And don't forget the I that's still out there. So kind of like factoring, where you have to know the factors, but you got to know which factors to use. Same thing here. I need to know the factors of 20. 1 and 20, 2 and 10, 4 and 5. But I've got to use the right set so that I can take the square root of something. Let's see, square root of 4 is 2. Thank you. So 2i root 5. All right, square root of negative 45. Take the negative out, make it an I. And then I'd like to split up 45 into two things. It would be nice if one of those things was a perfect square. So 9 and 5. And the reason we split it into 9 and 5 is because 9 is a perfect square. I can take the square root of 9. So 3i root 5. I know the negative will come out as an I. How could I split up? Let me pick on somebody. Ava, how could I split up 32 so that it has a perfect square factor? Okay, I'm glad you said 4 and 8. Let's do 4 and 8. It's not wrong, but it's not best. So 2i square root of 8. Not wrong, but also not done. Do you know why?
Because 8 can be 5.
Because I can do 8 as 4 and 2. So now I've got 2i times 2 root 2. That would be 4i root 2. Which is not wrong. But was there a different way, maybe a better way to split up 32? If you can, you'd like to use the biggest perfect square possible so that you don't have to do multiple steps. So let's do 2 and 16. Because the square root of 16 is 4, so 4i root 2. So eventually we got the same thing. And sometimes that happens, like you would never pick this route, But sometimes what happened to Ava happens to everybody. Like, you don't recognize what the biggest perfect square factor is. So you find one, you simplify it, and you're like, oh, that can do it again. So no big deal if that happens. Obviously, you'd like to find the biggest perfect square, but sometimes you miss, and that's okay. Remember, now we're going to kind of use the I stuff the other way. I squared equals negative 1. I squared equals negative 1. So 4I squared, I got to square both of those things. So Elisa, if I square 4I, 16I squared. All right, I'll even break it down a little further here, but Elisa didn't need to do that. She knew that if you square 4I, you get 16I squared. Square both pieces. But we now know that I squared is negative 1, so I'm going to replace I squared with negative 1. And be careful how you write this, right? This is not 16 minus 1. This is 16 times negative 1. So I get negative 16. For this second example, like order of operations, you need to do exponents before multiplication.
So, you said I equals negative 1. So what you say?
No, I squared is negative 1.
Oh, I squared?
I squared is negative 1.
Okay. That was a little bit confusing.
It is, because we use these. Here's the way we use them. When I squared shows up, we replace it with negative 1. When the square root of negative 1 shows up, we replace it with I. So those are kind of the same statement, but you use them in very different places. So when I squared shows up, replace it with negative 1. Okay, back to this one. Let's handle the square roots first, because that's the same thing as an exponent. So let's rewrite, like without worrying about other things, like one piece at a time. So Haley, what's the square root of negative 9? So the square root of 9 is 3, but what about that negative? That's the I. So Haley, what's the square root of negative 9? You got the 9 part right. But what's the square root of negative 1? I. So that part is 3I. Mateo, what's the square root of negative 25?
5I.
5I. Three I times 5I. Let's see. Kinley, what's 3I times 5I?
15i.
You got to do the I times the I. So 3 times 5 is 15. Well, what's I times I? I squared. Oh, and then you're taking Ben's question. That's okay. So, Ben, what do I do with 15 I squared?
You plug in negative 1.
Yep. And again, you do a few of these, you won't show this step. You'll just be like, oh, I squared, that's negative 1, so that becomes negative 15. If you haven't already, try that last one on this line, the 5I times 6I. It's not a trick question. Hayden, what's 5I times 6I?
30I squared.
Good. 30I squared. 5 times 6 is 30. I times I is I squared. But Mia, that's not an okay final answer. It's not wrong, but what else could we do? So what do I get for a final answer? Good. Negative 30. So when I squared shows up, replace it with negative 1. When square root of negative 1 shows up, you replace it with I. And so that's kind of the confusing part for today. All right, well, no radicals are allowed in the denominator, and I is a radical. So let's actually work a little bit easier problem here. Make sure our Algebra 1 brains are working. So I've got 5 over root 3. How do I fix that? Multiply both things. What do you mean by both things? I think you're right. Use the words, though. Oh, the fancy words. The numerator and the denominator. Yes. Because whatever you do to the top, you have to do to the bottom, so it doesn't change the fraction. So 5 root 3 over 3. Right? You did that a bunch in Algebra 1. Well, this example is similar because remember that I is the square root of negative 1. We can't have square roots in the bottom. So what do you think we multiply the top and bottom by on 5 over 3i? Okay, I heard I and I heard 3i. The problem with this isn't the 3. Like, the 3 is fine. The problem is the I. So let's just fix the I. So multiply top and bottom by I. So the top we get 5i. Layla, how about the denominator? What's 3i times I? It is 3i squared. Then that's fine. It's not done, but it's the right next step. Madison, what do we do with I squared? Good. And that looks kind of weird to write it like that, so we'd probably just do negative 5i over 3. But you can put the negative wherever you like. You can do 5 over negative 3, or excuse me, 5i over negative 3, or you could put the negative out front. Like, all of those are identical things.
I see.
I see what you did there. All right, that second one has, I would say, 2 issues in the bottom, although, wait a minute, there's multiple ways to do this. Thoughts on this one? I'll just throw it open-ended here. Okay, so we could simplify the 20. What would that give us? So, yeah, I heard the intermediate answer and the final answer. 4 times 5 in the square root, which would be 2 root 5. And I'm glad you opted to do that, because what can we do now? I can cancel the 2's out. I can cancel the root 5's out. And I'm just left with I. Here's my favorite wrong answer. One of my favorite wrong answers of all time, right there. Why is that not right? Because it's on the bottom, right? It's still in the denominator. Just because everything in the top went away doesn't mean that there's not a numerator, right? A better way to say this would be 2 divided by 2 is 1. Square root of 5 divided by square root of 5 is 1. And I've still got the square root in the bottom. So, Layla, what would you like to do to fix this? Good. Times the numerator and the denominator by I. So that gets me I over I squared. But what's I squared equal to? Negative 1. I over negative 1. I'm going to take off a point if you leave it like that, because that just annoys me. That's sort of like an unreduced fraction. Because what could I do with that negative? Just put it out front. Minus 1 point if you leave something over negative 1. That's kind of silly. Finish reducing that. Okay, so the new stuff is I. The trouble is you've got to incorporate that with all the old stuff about simplifying radicals. So let's do a few of these together to make sure we're okay. Why don't you try You get time. Why don't you try that top row, and then we'll come back and do 1 through 5 together. So try 1 through 5. Fernando, how about the square root of negative 49? 7i. The negative comes out as an I. Square root of 49 is 7i. Brooklyn number 2 turned into the hardest one for some people. But what did you get?
I root 10.
Good. I root 10. People try to split up 10, and I guess you could split it up as 2 and 5, but that's not helpful because those aren't perfect squares. So even if you write that on your page, hopefully as soon as you write it, you realize, wait a minute, I can't really do anything with that. So I root 10 is as good as it gets. Corinna, how about number 3?
Negative 36i.
Negative 36i. Do I need to show that one? There's a couple steps in that one. So the negative comes out as an I. So negative 3i. And then the square root of 144 is 12. So you got to know your perfect squares. And 12 times 3 is 36. So those folks that never learned their multiplication tables, that makes factoring tricky, and it makes this lesson tricky as well. Jordan, how about the square root of negative 28?
2i square root of 7.
Very nice. 2i root 7. And then Mason, how about that last one?
6i root 3.
6i root 3. 4 and 3, so 2 times 3 is 6. Yeah, 6i root 3. All right, well, let's see. We need to jump ahead to some harder ones here. Let's do number, which ones? Let's do, got a request for 15. You tell me, through 17, what do you like? What do I need to look at? All right, let's do 15, 16, 17. So you're okay with, excuse me. Thank you. 6 through 13. A lot of I squared equals negative 1 stuff going on those. Number 7. Let's see. So root 7 times I times root 14. So I could do 7 times 14, but I don't really want to do 7 times 14 because after we just talked about not splitting up things that don't have perfect square factors, why might it be a good idea to split 14 into 7 and 2? Yeah, I've got 2 root 7s. What's root 7 times root 7? It is root 49, but you can skip that step and just know that it's 7. So it is root 49, but the reason we like that is that's just 7. And then something similar can happen on number 8. Get the i's out of both of those. I and I. But then I could split up. Like 6 won't simplify it by itself. 15 won't simplify it by itself. But if I write them both as factors, they have a common factor that I can sort of fix. So 6 is 3 and 2. And again, normally that wouldn't do me much good, right? Like, who cares? I can't take the square root of 3 or the square root of 2. But I'm peeking ahead. How could I write 15?
3 and 5.
3 and 5. And now that does help, because what's the square root of 3 times the square root of 3? 3. 3, I times I is I squared. 2 and the 5, I can't do anything with that, so I'm going to just put those back as, whoops, I squared. And then I'm not quite done because what's I squared equal to?
-1.
Negative. So negative 3 root 10. Let's skip ahead to 15. There's maybe a couple things you could do first on 15. Yep, so we could say I don't like the negative in the square root, so let's take the negative out as an I. And now I've got two problems with the denominator. So what should I multiply the top and bottom by? I is part of the answer, that'll fix the I. But I also don't like the root 3, so I need to multiply the top and bottom by I root 3. The I will fix the I's, the root 3 will fix the root 3's. So I root 3 in the top, that's the easy part. How about the bottom? Okay, I squared times 3, I like that. I'm not done yet, but I like it. Because what's I squared equal to? Negative 1. So I root 3 over negative 3. Or if you like the negative out front, that's fine too. What don't you like about 16? What could we fix in the denominator? Yeah, we could just kind of jump ahead and say that that's 3i. Square root of 9 is 3. Square root of negative 1 is I. Oh, now I got an I in the bottom. Oh, actually.
Can you add an I to the top and then the bottom?
Yep, I could add an I to the top and the bottom. So now I've got negative 9i over negative 3. We're jumping steps here, which is fine. Like, you're going to do this so much that instead of writing I squared, your brain is going to hopefully get to the point where you see I squared, you're like, oh, that's negative 1. So that makes a negative 3 in the bottom. Oh, what's that reduced to? 3i. How about 17? What would you like to do first on 17? So, a bit of a trick here if you catch it. Yeah, 24 and 8, they're both in the house, so I can reduce that. So rather than fixing 24 and fixing 8, let's just do 24 divided by 8. Let's reduce that. Make life easier for us. So that's root 3 over 3i. Because 24 divided by 8 is 3. So you peek ahead, you see that can happen on 18, 19, and 20 as well. You can reduce the square root stuff. Make life a little easier. I'm not done with 17 though, Emery. What's wrong with 17? Why can't that be my final answer?
You can't have an I in the bottom.
Perfect. So how do I fix the I in the bottom?
So times it by an I on the top and the bottom.
Perfect. So, be careful with writing it like this. We like to put the number or the letter out front because if you put it at the end, it's not real clear if it's inside the radical or not. So, that's not wrong if you can convince me that I is not in the radical, which is why we like to put it at the front, because then it's obvious it's not under the radical. Ocean, how about the denominator? What's 3i times I? I mean, Emery's right, but do you know where the negative 3 came from?
The I.
Yeah, the I times the I is I squared. That's negative 1, so it's negative 3. All right, 18 through 20 have that same, or at least that similar step where you can reduce a little bit before you get started. Make life a little bit easier. Flip to the back where the real fun begins. Got some fraction work here. All of it's our homework. The back is no imaginaries on the back. But, man, that's a lot of fraction work. Let's see. Do you remember how to fix 24? Look at 24. It's got a square root in the bottom. Do you remember what you do to fix that one? Got to multiply by something. If you multiply by the square root of 3 and you distribute it, it would fix the 3, but it would mess up the 1. So there's a trick to this one. You have to multiply by 1 minus square root of 3. Does that sound familiar at all? Yes or no? I'm just curious. Bunch of no's. Okay, that's okay. It's called the conjugate. Don't really care what it's called. But you change that middle sign. And when you change that middle sign and you FOIL,
That one I.
there's no I's on the back at all. The back is just about fractions. So if I FOIL, I get 1 minus root 3 plus root 3. And then what's root 3 times root 3? 3. Right, it is root 9, but let's skip that step. Root 3 times root 3 is 3. And then this always happens. Those middle terms will cancel out. And I end up with negative 2 in the bottom. Okay, so officially all of that is the assignment, but you're probably going to struggle with 26, 28, and 30. So definitely try, let's say try through 25, and we'll do some of the rest tomorrow. So we have to FOIL the top. So first, outside, inside, last, and then let's see, that's negative 4 plus 2 root 3. Alright, there's a ton of math steps in number 24. I can divide both of those by negative 2. So 2 minus root 3 is my final answer. Lovely. Uh-huh.